Professor Deb here. Today we're going to be talking about technical mathematics, and in particular the factor and remainder theorem. At any time, stop or pause the video to examine the material more closely. Let's take a look. Let's get started and take a look at a problem and how we work this. In this problem, we have a polynomial and we have an answer for x. Now what we want to do is check that answer to see whether it actually divides into that polynomial or there is a remainder. So let's start by putting it in. Negative 2 raised to the fourth, 2 times negative 2 squared plus negative 2. Alright, negative 2 to the fourth gives us 16. Negative 2 squared is 4 times negative 2. I'm sorry, we'll just use that 2 times negative 2 squared. Should be, we carry that minus sign down, and then we get 8. We carry that plus sign down, and we get negative 2. So 16 minus 8 minus 2 gives us 6. 6 is the remainder. So in this case, 2 is not an actual factor of this polynomial, because when we put 2 in there, we actually have a remainder of 6. Let's take a look at another problem. This is how the remainder theorem works. If p of x, and that was our negative 2, or p of x was the polynomial, the big long polynomial, is divided by x minus a. In this case, we were given a as negative 2. Until the remainder does not contain x, then the remainder equals p of a. Oh boy, that's a lot of words. Let's put it into practice. Let's just go right into. Okay, here we have another question. And we're given x minus 3. Alright, when we have to do a little finding for x first. X, that's a minus 3, equals 0. Therefore, x equals 3. Okay? And that's the number we're going to put into this polynomial. So let's say remainder equals, we want to do p, and this is a function. We're going to put 3 in for x. So every time we see x in this function, we're going to put 3 in. So let's do that. We've got 3 cubed plus 2 times 3 squared minus 12 times 3 minus 9. Okay, a little math is in order here. 3 cubed is equal to 27 plus 18 minus 36 minus 9. And if we put that all together, we'll come out with that it equals 0. The remainder is 0. And what that says is that if this polynomial were divided by this binomial, that there will be no remainder. No remainder, okay? So all we're trying to do here is we're taking the number that they're giving us, putting it into the formula, and finding out whether they're a remainder or not. Okay, here's one more problem. In this case, we've got x minus 7. Well, you know we'll set that equal to 0. So x will equal 7. All right, we're going to put it in again. P of 7 equals 2 times 7 to the 4th. Better put that in parentheses. It almost looks like 274, doesn't it? I would not want to multiply that in my head. So we'll go with a 2 times 7 to the 3rd minus 6 times 7 squared minus 14 times 7, and then we have to bring down that minus 7. Oh boy, these are big numbers. I'm going to have to get my calculator out here. 7 to the 4th times 2. Oh boy, this is a big number. Wonder what we're going to come out with these big numbers. 4802 minus 686 minus 6 times 49 should be 294. Fourteen times 7 should be 98, and minus another 7. When we put this all into our calculator, it doesn't add up to 0. This time it adds up to 3,717. That is a remainder. Therefore, x minus 7 does not go in evenly, or 7 is not a factor of this polynomial. All right, try this one on your own. Stop or pause the video and put in this one and see whether you can determine whether there's a remainder or whether there's not. Remember to change this around x minus 1 so x actually equals 1. Check your solutions in the other part of the website, and then come back and we'll dive into the factor theorem. Here's the factor theorem. Hope you did well on the last problem. A polynomial, p of x, contains x minus a as a factor if p of a equals 0. Well, we already did that one. You remember? And we came up with 0, and we said, yes, it's a factor. Well, now we're going to test for the factors. We're doing the same thing, really. We're just saying, yes, there's a remainder, or yes, it's a factor. But the process is exactly the same. Okay, we have x plus 1. So x equals negative 1. Now, because of that formula, they like to determine that it's not really x, it's called a. A equals negative 1. So we'll go along with that. So p of negative 1, now we're trying to find out whether it's a factor. Negative 1 to the 4th, well, this shouldn't be too bad. We're working with ones. Minus 9, negative 1 to the 3rd, plus 18 times negative 1 to the 2nd, minus 3. Okay, let's see if I can break this down a little bit. Hopefully you've got your calculators out and you're checking me. This should be 9 plus 18 and minus 3. And if I add that all together, I'm going to get 25. No good. That's not what we wanted to see. No. It did not come out as 0. Therefore, this factor, x plus 1, is not a good factor for this polynomial because it has a remainder. Okay, so the difference between the factor theorem and the remainder theorem is if it asks you to use the remainder theorem, then you specify whether there's a remainder or not and what that is. If it asks you if it's a factor by using the factor theorem, your answer is yes if it comes out 0 and no if it comes out with a remainder. All right, but essentially you are doing the same process, so don't let it confuse you. Okay, here's another one. We go all the way up to the 5th now. So now we're really going to work it. Okay, x minus 2. I'm going to put down that a again because they like to use that nomenclature. A equals 2. All right. Back to it. 2 to the 5th. 3 times 2 to the 4th minus 14 times 2 to the 3rd. These are getting bigger and bigger, and it's taken me longer and longer just to write them out. 14 times 2 to the 2nd, and I'm sure you've noticed by now that my 2's are strange. Whoops, that shouldn't be a 2 anyways. That should be a 4. Minus 24 times 2. All right. Hope your calculators are checking me on this. I make my share of mistakes. 96. And this should be 48. Now this is a minus 112. 4 times 4 is 16. Minus 48. All right, dump that all into your calculator. And what do we get? 0. Wonderful. So now let me answer the question. We got 0. So therefore, is x minus 2 a factor of this polynomial? And your answer is a big yes. It has a remainder of 0, so therefore it is a factor. Yes. All right, here's one for you to try. Remember, change this into a will equal negative 3. Stop. Try the problem, and then check on the website for the solution. Hope you've enjoyed this video lecture. There are many other video lectures similar to this that should be contained on the website. Thank you.